Welcome back, everyone. In our last explainer, we laid all the groundwork, right? We talked about the theory of data structures. Well, today we're done with theory. It's time to get our hands dirty and actually move from theory to practice. And trust me, we're about to unlock a programming superpower that's going to completely change how you write code. So here's what's on the agenda. We'll do a super quick refresher on data structures, then jump right into putting them to work. After that, I'll introduce you to the power of functions. This is a real game changer. We'll combine everything and then, of course, finish up with the key takeaways. All right, first things first, let's do a quick refresher on the tools we already have in our programming toolbox. Think of these as the raw materials, the fundamental building blocks we're going to be using today. You remember these, right? Lists are for your everyday, changeable, ordered stuff. Tuples are their cousins. Fixed, you can't change them. Sets are all about uniqueness, no duplicates allowed. And of course, dictionaries for those super useful key-value pairs. Just keep these basic jobs in mind because we're about to use them. Okay, that's enough talk. Theory is one thing, but the real magic, the real learning, happens when you start writing actual code. So let's stop talking about these structures and start using them to solve some real-world problems. So let's kick things off with a classic challenge. I give you a list of numbers. Your job? Find the biggest number in that list. But here's the catch. You have to tell the computer how to do it. No just looking at it and pointing. And here's how you do it. Check out this code. First, we make a guess. We create a variable, let's call it max_num, and just assume the very first number in the list is the biggest for now. Then we start a loop, that's the part in orange, to go through every single number in the list. Inside that loop, we have a simple question. Hey, is the number I'm looking at right now bigger than my current max num? If the answer is yes, we just update max num to this new, bigger value. And we just keep doing that until we've checked every number. So the key thing to get here is the logic, the pattern. It's a really simple but super powerful three-step dance. Step 1, make an assumption, a baseline. Step 2, loop through everything and compare against that baseline. And step 3, if you find something better, update your assumption. That's it. It's a fundamental concept you'll use all the time in programming. Awesome. Okay, let's tackle another one. This time, we're going to switch gears and use a dictionary. So picture this. We've got a dictionary that stores student names and their scores. How do we pull that info out and, display it in a way that makes sense? And this is a really elegant way to do it. Take a look at that for loop. We're using a special little helper called .items on our dictionary. What's so cool about .items is that it's smart. It knows a dictionary has keys and values. So with each pass of the loop, it hands us both the name and the score, neatly packaged into two separate variables. All we have to do is print them out. So handy. Okay, so writing this code is great. It works. But what happens when you need to find the max number in 10 different lists? Or you need to print out student scores from 20 different dictionaries across your program? Are you really going to copy and paste that same block of code over and over and over again? No way. That's messy. It's inefficient. There's got to be a better way, right? And of course there is. This is where functions come in. A function is basically a reusable block of code that does one specific thing. The best way to think about it is like a recipe. You write down the steps for baking a cake once. You give that recipe a name, like my awesome chocolate cake. Then whenever you want to bake that cake, you don't rewrite the recipe, you just follow the recipe. A function is your own custom reusable recipe for code. And the benefits here are just huge. I mean, first off, you avoid repeating yourself. This is a massive principle in programming called DRY. Don't repeat yourself. Second, your code becomes so much cleaner and more organized. And third, you can reuse that little piece of logic anywhere, anytime. It's a total win-win-win. And you know what? Making one is actually super simple. You just use the keyword def, which is short for define. Then you give your function a name, followed by some parentheses. Any code indented underneath that line belongs to the function. Then, whenever you want to run that code, you just call it by its name. That's it. Greet, boom, it runs. But this is where it gets really interesting. We can make these functions way more flexible. See that little name variable inside the parentheses? That's called a parameter. Think of it like a blank spot in our recipe. It's a placeholder for information we can give the function when we call it. So when we say greet Rahul, we're filling in that blank. The function takes Rahul, plugs it into the name spot, and gives us a totally custom greeting. And it's not just a one-way street. functions can also give you something back. They can do a calculation and hand you the answer. That's what the return keyword is for. Our add function here takes in two numbers, adds them up, and then return literally sends that result back out. We can then catch that result and store it in a variable like result here. This is absolutely crucial for any kind of calculation. All right, now for my favorite part. Let's put this all together. We're going to go back to those little programs we wrote earlier and give them a major upgrade with our new superpower, functions. So you remember our first challenge, right? Finding the biggest number in a list? That code we wrote? It works, but it's kind of a one-trick pony. It's not reusable. So let's see just how much better, how much cleaner we can make it by wrapping it up inside a function. Just look at the difference here. On the left, that's our original code. It's stuck, hard-coded to work on that one specific list. But look at the right. It's the exact same logic, but now it's tucked away inside this clean, beautiful, reusable function called findMax. Now we can throw any list at it, and it'll give us the answer. We've turned a one-off script into a powerful general-purpose tool. Let's do that one more time. Let's build another tool. This time, our goal is to create a function that can look up a student's score in that dictionary of ours. And there you have it. This search student function is built for flexibility. It takes two pieces of information, the dictionary you want to search in, and the name of the student you're looking for. It just does a quick check. Is this name in the dictionary? And if it is, it returns the score. It's another perfect example of building a clean, simple tool that does one job and does it well. Wow, okay, we have covered a ton of ground today. We've gone all the way from the basics to actually building our own tools. So let's just take a second to recap the really powerful new skills you've picked up. This was a huge leap forward for you, seriously. You went from just knowing about data structures to actually using them to solve real problems. And even more important than that, you now know how to take any piece of logic, any little recipe of code, and package it up into a reusable function. This is a fundamental shift in how you'll approach problems. You're really starting to think like a programmer. Because at the end of the day, this is what programming is all about. It's about seeing a problem and having the ability to build your own tool to fix it. And you now have the core skills to start doing that. So the only question left is, what tool are you going to build first? What problem are you going to solve? Thanks so much for watching.